Hello everyone, today we'll be looking at 9702, which is Cambridge Physics, from October-November 2018, paper 2-1, question 1. I would suggest you to give it a try first before watching this, so that you can identify the places that you need to improve on. Okay, so let's begin. We will skip 1A because it's just definitions, it's not much of a challenge. Let's go to the more interesting part. Alright, a remote controlled toy car moves up a ramp and travels across a gap to land on another ramp, as illustrated in figure 1.1. Okay, the car leaves ramp P with a velocity of 5.5 meter per second at an angle theta to the horizontal. The angle, this is the velocity. Alright, the horizontal component of the car's velocity as it leaves the ramp is 4.6 meter per second. The horizontal component of the car's velocity. Okay, the car lands at the top of ramp Q. Okay, the tops of both ramps are at the same height and are a distance of d apart, and they are the same height. Okay, that means since they are the same height, it means you can have a midpoint here. Okay, air resistance is negligible. Air resistance is negligible means your acceleration is 9.8 meter per second square. 9.81, more accurate, 9.81 meter per second square. Alright, show that the car leaves ramp P with a vertical component of velocity of 3. So just now in the question they gave us the horizontal. Now they want us to find the vertical. Alright, for this question there are actually two ways to solve it, but I would recommend the first way due to the marks allocated, and the first way would save you a lot of time. Okay, so let me show you the first way. So I say first way. Okay, we know the velocity is 5.5 and we know the horizontal component is 4.6. So how do we find the vertical? Okay, this is our velocity, right? This is our horizontal velocity and this is our vertical velocity. If we redraw this again, you can actually bring this vertical velocity to this side. So this, if you can see, is actually a right angle triangle. So let's put in the values in the picture. Our V is 5.5. Our horizontal component of the car's velocity is 4.6, and this is what we want to find, the vertical component. So we can use Pythagoras theorem here. So we take Vy square equals to 5.5 square minus 4.6 square. So what is our vertical velocity? Square minus 4.6 square. Let me show you. Don't forget to square root it. You'll get 3.01, and it's 3.0 meter per second to two significant figures. It's 3 meter per second. There you go. You're shown it. Simple as that, you will obtain your first mark. Now, what is the second method? So the second method is where we will involve the usage of the angle. So second method is where we find angle. Then we will find the vertical component. Just now the first method, we are using Pythagoras theorem. Pythagoras theorem. So second way is using cosine and sine, where we'll find the angle. Okay, let's write this. Okay, just now we have drawn our triangle like this, right? This is 5.5. This is basically our V. We are going to find what is our Vy, and our Vx is actually 4.6. Okay, so Vx is actually V cos theta. How is it so? We know cos theta equals to adjacent over hypotenuse. Am I right? Now, where is your angle? Where is your theta? This is your theta. Because you see here, this is the car going up and your theta angle is here. So that means when you draw your velocity diagram, your theta is here. Okay, get it so far? Okay. So cos theta is adjacent over hypotenuse. What is our adjacent? This is our adjacent, right? This is our hypotenuse. So cos theta equals to adjacent over hypotenuse. Therefore, V cos theta equals to Vx. Usually in exam, you don't have to derive. You just have to know this formula. X is cos theta. Okay. How about Y? It's the same thing for Y. Y, we will use sin theta. Sin theta is opposite over hypotenuse. Am I right? So, sin theta, opposite is the vertical velocity. So, it's Vy over V. Therefore, Vy equals to V sin theta. So, these are your two formulas that uses angle. So, now they give you the horizontal velocity, which is 4.6, right? So, you can find 4.6 equals to 5.5 cos theta. Why 5.5? Because the velocity is 5.5, right? So your theta would be, make sure your calculator is in radian, very very important. If not, you'll get a very different answer. Usually in physics, it's always, no, make sure your calculator is in degrees, not radian, yeah? Make sure your calculator is always in degrees, not in radian. Sorry about that. It actually must be always in degrees. Okay, so this is your angle. Now we have our angle. Can we find our vertical component of the car's velocity? Of course. Vy equals to 5.5 sine the angle 33.24. You will get 3 meter per second as your answer. You will still get the same answer. But think about it. Looking at these two methods and the marks and the time that you have for paper 2, which way do you think is better? Of course, I would 100% recommend the first way. Simple, straight to the point. If they ask 2 or 3 marks, then maybe this is the method to do. Otherwise, stick to the first way. Alright? Okay, so that is Roman 1. Now, Roman 2. Determine the time taken for the car to travel between the ramps. Okay. So now, what information do we have? We know at this point our vertical velocity is 0. However, our horizontal velocity is still 4.6 meter per second, because horizontal velocity is constant throughout the motion. Why? Because there is no force acting horizontally. There is no external force acting horizontally. Therefore, the horizontal component of the car's velocity will remain constant. However, the vertical velocity now is 0. It will change throughout because there is force, which is the gravitational force, which is the gravity. Because as you go up, so throw the ball up, or for example, throw the ball, there's a gravity acting downwards, right? So that is why the velocity in the vertical component is actually changing throughout. So at first, the velocity will, at the very high, first it will be 5.5, then probably reduce to 5.3, slowly decrease until it hits 0. Then after it hits 0, it will increase again, in the opposite direction, of course lah. It will not be in the same direction as this going up, because first you go up, then you go down. So up is one direction, down is another direction, right? That's why I draw in another direction. So we know at this point, velocity in the vertical direction is 0. So that's one point we have. Vy equals to 0. What is our initial velocity? 5.5. No, not 5.5. Oops, mistake. Our initial velocity is 3 meter per second. Why is it not 5.5? We are talking about vertical components now. So vertically, here is 0 for Vy. So what is the vertical component initially? It was 3. We find. So our vertical component initially is 3, not 5.5. 5.5 is the initial velocity, not the initial vertical component velocity. There's a difference, yeah? Okay. So we know the final, we know the initial. So now, what can we do with this information? Nothing much. So how are we going to solve this is, I've divided this thing into 2 sections. So by finding the time from here to here, you just have to multiply by 2 to know what is the entire time. Why? Because they did say both ramps are the same height. That's why I can safely divide them and say these two have the same time. Then after I find this time, let's put it as T1. After I find this time, to find the entire time, I just take T1 multiply by 2. Okay, so let's find one side. Because with the information that is provided to us, this is how we can calculate it. Okay. What is our A? Our A is 9.81. But since as the car leaves the ramp, the acceleration is acting downwards. Am I right? Like the ball, as the ball will show, the acceleration is acting downwards. Therefore, it should be negative 9.81 meter per second square. So now we're going to find T. We can use one of the kinematics formula where V equals to U plus AT. Your V is 0, your U is 3, your A is negative 9.81 and your T. So you do algebra, you will get your T as 0.3058. But this is not your final answer. Your time taken is 0.3058 multiplied by 2. Remember. So this is your answer. Okay. Nicely, you get your 2 marks. So be careful on what velocity are you taking. Is it vertical? Is it horizontal? You can't take one as vertical, one as horizontal. You can't do that. It doesn't work that way. Okay. Now, they want us to calculate the horizontal distance between the tops of the ramps. That means they want to calculate this. We know our velocity horizontally, because they ask for horizontal distance. That means we can make use of our horizontal velocity. Our horizontal velocity is 4.6 meter per second. Our time taken is 0.61. Time taken, right? Whether is it vertically or horizontally, you're going to have the same time. You're still going to start and end at the same place. You're going to have the same time. Time will not change. The difference is the velocity that will change, which is the horizontal and the vertical here. So now they want us to find the horizontal distance between the tops. If they ask for vertical distance, it's actually this here. Okay, let me erase this. If it's vertical distance, it's actually this here, not this. Now they're asking for the horizontal distance. Now they want us to find this one, D, horizontal. If it's vertical, then you must make use of the vertical component. This is the vertical distance. Okay, now since they want horizontal distance, we know V equals to distance over time gives you distance equals to velocity multiplied by time. Therefore, we take 4.6 times 0.61. What does it give you? 2.8 meter. So remember, make sure your answer is in minimum 2 significant figure. Minimum 2. You can put 3, no problem, but minimum must be 2. If your answer is, let's say this one, let's say it was 2 meter. This is wrong. You must write it as 2.0 meter because 2 SF. Remember, very important. Even though your answer is right, they'll mark it as wrong. Two significant figures. Okay. Moving on to the fourth part. Calculate the ratio kinetic energy of the car at its maximum height and the kinetic energy of the car as it leaves the ramp P. Okay. At its maximum height is here. I'm going to erase the others so that we can see it clearly. The one at this point and as it leaves the ramp. As it leaves the ramp, this is your velocity. Okay, so no problem. What about your velocity at this point? You know you have no vertical velocity, but your horizontal is 4.6. So what will be your velocity at this point? Since your vertical is 0, so that means there's no vertical. So what will be your resultant velocity here? Definitely your velocity here will also be 4.6 only, because there's no vertical, there's only horizontal. So your resultant velocity will be 4.6. At this point, you have vertical 3, you have horizontal of 4.6, your resultant initial velocity here is 5.5. At this point, here you have no vertical, you only have horizontal. So your resultant must be 4.6. Okay, so we know our velocity at these 2 points. Let's calculate it. So at the maximum height, it is 1 over 2 m, because kinetic energy has a formula 1 over 2 mv squared, right? So 1 over 2 m, they didn't give the mass of it, right? But I think we will be able to cancel it out later. At maximum height, it is 4.6 square. As it leaves the ramp, it is 5.5 square. So these two can be cut, and this will give you 0.70 as your ratio. So this is your ratio. In physics, ratio is always given in decimal. Always. It must always be given in decimal. Don't give fraction for physics ratio. For maths, yes. For physics, it's not really suggested. Best to give in decimal. Okay, you're done with the fourth one. Nicely, you got your 3 marks. Make sure you take the right velocity. Very important. Usually students might take the wrong velocity and you will get the wrong answer. So make sure you get the right one. Okay. Last one. Last question. Ramp Q is removed. Oh, so there's no longer, this is gone. Okay. The car again leaves ramp P as in B and now lands directly on the ground. The car leaves ramp P at time t equals 0 and lands on the ground at time t equals to t. Capital T. On figure 1.2, sketch the variation with time of the vertical component v subscript y of the car's velocity from t equals 0 to t equals to capital T. Numerical values of v subscript y and t are not required. Okay. Just now if you see, I go draw the pattern. Right. Okay, first, at this point, and let me erase, okay. 5.5, then it will slowly decrease to 0. Then, from 0, it will increase back in other direction because it's moving, because it's moving in the opposite direction, right? So increase, and increase. So, you know at some point in the graph here, which I'm going to take a middle point here, your graph has to hit here. Right? It has to pass through this particular point. So your graph will simply just be a straight line like this. This is, okay, let me draw the car here. This is when the car is moving up. Okay, I think I'll draw it here. And the car is moving up. Okay, so it is in the positive direction. And why is it going down? Because remember I said it will slowly decrease 0 until the maximum height it will become 0. Then when it goes down, back, it will slowly increase. That's why slowly it is increasing its magnitude. Slowly it will increase, right? Because remember, here -1, let's say here -2, here -3, it slowly increases, but in the opposite direction. That's why I draw in the negative side, but you don't have to put your values here lah. So that's why it is a straight line. Make sure you use ruler and draw, okay? I can't really draw with the ruler, so it's a bit hard. So this is how it looks like. So few things to note. What is vertical component of velocity? What is horizontal? And where is it 0? Where is vertical component 0? It's at the maximum height. Why I've been saying here 0? Because it is at the maximum height. Because imagine you try to visualize. Imagine you throw a ball up at not a very long time. It's just a very short period of time. It will stop moving for a bit. Just for a bit. Then it's going to fall down back. When it reaches its maximum height, the vertical velocity will be 0. Okay. Yeah. So I was saying, make sure you know how to calculate all these formulas, kinematics. Best to remember. If you know how to derive it, it's the best. Because in that case, you don't have to remember. You just have to understand. So from where this formula comes, you have to understand it. Because you can't memorize physics. Honestly speaking, that's not how it works. You have to understand the formula. Eventually, it'll stick in your brain. Okay, this is actually a very simple question. Once you understand the concept, I believe you'll be able to answer it well. Thank you for watching this video. That's all for today. I'll see you in the next video. If there's any question, please let me know in the comment. Don't forget to like, share, and subscribe. Thank you. Bye bye.